What is physical decomposition? Physical decomposition means separating the product or sub-assembly directly into its subsidiary sub-assemblies and components and accurately describing how these parts are joined together to create the behavior of the product. For example, on this figure, as you can see here, this is the bicycle, and then this is the figure related to physical decomposition, where we can see how parts in bicycle are being separate or being divided into their component or parts. For example, in bicycle we have frame, and then seat, wheels, brake, and gear. And then under the wheel also can be decomposition, physical decomposition again, where the wheels are formed by rim, spokes, and tires. Now, what is functional decomposition? So, functional decomposition is a top-down strategy where the general description of a device is refined into more specific arrangement of function and sub-functions. So, as you can see here, this is a figure about transport passenger from point A to point B, where this is the overall function which let's say we call it a machine. So this machine should able to transport passenger from point A to point B, and then among the sub-function that should have in this machine is first drive mechanism to produce power. So there should be a sub-function related to mechanism to produce power, and then the second sub-function in this machine should be the brake mechanism to stop, and then there is a sub-function related to steering mechanism on controlling the direction of the transport, and then sub-function in terms of structural support, where to support all these such as drive mechanism, brake mechanism, and steering mechanism is located on this machine. So now let us see some example how to perform the functional decomposition. So the example is the mechanical pencil. The goal of functional modeling is to decompose the problem in terms of the flow of energy, material, and information. 4 steps in use in performing functional decomposition is: Step 1. Determine the overall function that needs to be accomplished. Step 2. Create sub-function description. Step 3. Order the sub-function. And then step 4, refine sub-functions. Step 1, determine the overall function that needs to be accomplished. The goal is to generate a single statement of the overall function on the basis of the customer requirement. So, the overall function is to, for mechanical pencil, is to capture lead markings on paper. So, as you can see here, there is a human energy, and then there is a paper and pencil lead, and end up there will be the paper will be marked by the pencil lead. So capture lead markings on paper. This is the overall function. Step number 2, create sub-function description, where the goal is to decompose the overall function by identifying the sub-function needed. We know that from the previous slide, the identify overall function is to capture lead marking on paper. So now in step number 2, we need to think what is the sub-function related with the overall function. So In order to the lead can be marked on paper, we need to move the pencil near to the paper. And then after that, we need to position the lead, the mechanical pencil lead on paper. And then we need to guide the lead across the paper. And then when we want to make marks on the paper, we need to regulate pressure of lead on paper. So this is the sub-function related to the overall function. We have moved pencil to the paper, the first sub-function, and then we need to position lead on paper. This is the second sub-function. And then after that, we need to guide the lead across the paper. So this is the third function, the third sub-function. And then last, we need to regulate pressure of lead on paper. So this is the fourth sub-function. All of these sub-functions will ensure that the overall function, which is to capture lead marks on paper, can be done. Step 3, we need to order the sub-function. The goal is to add order to the function generated in the previous step. The order means that we need to arrange all the sub-functions into their respective arrangement. So we need to consider, we need to think, we need to identify which sub-function to be the first sub-function and which sub-function to be followed after the first sub-function. So in this example, the first sub-function that we arrange is move pencil to the paper for the first sub-function, and then the second sub-function, we will position the lead on paper, and then the third sub-function, we will regulate pressure of the lead on paper, and last, for the fourth sub-function, we will guide the lead across the paper. So this is the sub-function in terms of their arrangement. In step 4, we will try to refine sub-function. So the goal is to decompose the sub-function structure as finely as possible. So this means examining each sub-function to see if it can be further divided into sub-function. So step number 4 is to find whether we can add more sub-function into this schematic diagram or not. If you can add a new sub-function, smaller sub-function in the schematic diagram, so you can add. But if you cannot add the sub-function, new sub-function, so it is just okay. So let's say we look to the schematic diagram. So we can see that sub-function, for each sub-function there is a function flow. For example, move pencil to paper. So we can see there is 3 flow. Human energy flow, which is the hand of the human who grip the pencil and move the pencil to the paper. And then also there is a flow of material of paper, where the paper is moved towards to the pencil. And then there is also a material flow, which is the pencil lead is moved near to the paper. So basically, for this sub-function, move pencil to paper, there are 3 flow: human energy, material in terms of paper, and pencil lead. Then the next sub-function is position lead on paper. Also have 3 energy flow, which have also function flow, which is first is the energy flow, human energy, where the hand of the human position the pencil lead on paper, and then paper is positioned also respect to the pencil lead, and then lead also is positioned into the paper. So as long as we can see this schematic diagram. We can see what types of the function flow related to the subfunction. So basically, this is the detail, the complete detail of schematic diagram for functional decomposition. Okay. So this is the example of functional decomposition of washing machine. So as you can see, there is many subfunction available in this schematic diagram. So we have, for example, we have store detergent function, and then we have import water function, subfunction, and we have mix and water detergent subfunction. Later we have also mix laundry and water subfunction, and then rotate laundry inserts, separate laundry inserts, and export such and export clothes. So this is the example of washing machine, the functional decomposition of washing machine. And then each of the subfunction is connected with the flow of function, whether it is a material, signal, or energy. So the thick one is material, where laundry wash, and then the detergent also is a material, and then water is also a material. So it symbols a thick straight line. Okay. And then for example, for signal, so signal, let's say from input signal, this is the subfunction, and then input signal means that the flow is the signal. So we represent the line, the dash line here. Okay, and then go to the subfunction of start washing program. So it also the outcome is the signal also, and then regulate washing program also give signal also, and then convert energy into rotational energy. So this subfunction of convert electrical energy into rotational energy. The input have from two types of function, which is signal and energy. So the energy we symbolize as a thin line, a thin straight line. Okay. For example, from input electrical energy into the converting electrical energy to rotational energy. So there is a flow of energy here. Okay. And then from convert electric energy into rotational energy, so the electrical energy will go into the rotate laundry inserts. So basically, this is the example of washing machine functional decomposition. So